One of the most eagerly anticipated astronomical events is the supernova of Betelgeuse, located in the well-known shoulder of Orion. Betelgeuse is a red supergiant star nearing the end of its life. It is one of the night sky's brightest stars, but in late 2019, it mysteriously began to dim. This dimming was so evident that it could be observed with the naked eye. For several months, Betelgeuse's brightness waned, leading observers to wonder if it had reached the end of its life. After a few months, however, the red giant's brightness returned to normal. When astronomers used some of the world's most powerful telescopes to investigate, they discovered the cause of what they called the Great Dimming. Betelgeuse is nearing a supernova as it approaches the end of its existence. But when and why is this supernova expected, and could it be disastrous for Earth? Betelgeuse, the brilliant ruby-red star, sits in the upper right shoulder of the winter constellation Orion the Hunter. Known as Alpha Orionis, it is the constellation's second brightest star after the blue supergiant Rigel. Betelgeuse's variable nature, size, and unique name make it an intriguing object for study. Usually, stars named Alpha are the brightest in their constellations, but Rigel outshines Betelgeuse. Still, Betelgeuse is known as Alpha Orionis due to its prominence, size, and reddish hue. Betelgeuse ranks as the seventh brightest star visible for most of North America, Europe, and Canada, and it is the 10th brightest star overall. The name Betelgeuse likely stems from an Arabic phrase meaning, the armpit of the giant, with the giant representing Orion. Some scholars think Betelgeuse might represent a hand or shoulder rather than an armpit. Although ancient star charts depict Betelgeuse as Orion's right shoulder, its exact meaning remains uncertain. Surprisingly, astronomers cannot pinpoint Betelgeuse's exact distance from Earth, though they estimate it to be between 430 and 724 light-years away. Betelgeuse is the brightest red supergiant star and the closest to Earth, with only around 200 red supergiants identified in our galaxy. Betelgeuse is 16.5 times more massive than the Sun, and with 126,000 times the solar luminosity, it is visible from 548 light-years away. Its surface temperature is cooler than the Sun's at about 3,600 Kelvin, with only 13% of its energy in the visible light spectrum. If human eyes could detect light at all wavelengths, Betelgeuse would surpass Sirius as the brightest star in the night sky. Betelgeuse is also colossal, with a radius about 764 times that of the Sun. If placed in the Sun's position, Betelgeuse would reach beyond Jupiter, engulfing Mercury, Venus, Earth, and Mars. The star sheds about one solar mass every 10,000 years, surrounded by a nebula from the material it ejects unevenly in all directions. Betelgeuse, thought to be between 9 and 10 million years old, is relatively young but nearing the end of its lifespan as a red supergiant. When stars form, they are primarily composed of hydrogen, which fuses under gravity to create helium in their core. This fusion releases energy, which radiates to the star's surface and then into space. As the star ages, its hydrogen depletes, and helium fuses into carbon. Eventually, heavier elements like iron form, which absorb rather than release energy, leading the star to collapse in on itself, sparking a supernova explosion. A supernova, one of nature's most powerful forces, can release more energy than 10 billion suns. As stars evolve, their color shifts according to their stage, from hot, blue young stars to cooler red giants. Greek astronomer Ptolemy, 90 to 168 AD, described Betelgeuse as ruddy, while earlier Chinese astronomers had noted it as yellow, possibly suggesting Betelgeuse was once a yellow supergiant. Massive stars burn through their hydrogen quickly, resulting in shorter lifespans. Although Betelgeuse is only around 10 million years old, it is approaching the end of its life, unlike our Sun, which is in its middle age at approximately 5 billion years. Because Betelgeuse is near death, it could go supernova soon, although there is debate on when this might occur. Betelgeuse undergoes 2 brightness cycles, with the second lasting about 100 days every 5 years. This cycle causes its outer shell to expand and contract, changing the star's circumference and average temperature. When Betelgeuse dimmed unexpectedly in 2019 and 2020, astronomers speculated that the star might be nearing the end of its life. Betelgeuse has been studied extensively since the 1st century BCE. Recently, it was discovered that Betelgeuse was expelled from its original position in the Orion OB1 association, which includes stars in Orion's belt. It now moves through the interstellar medium at 30 kilometers per second, creating a bow shock over 4 light-years wide. Astronomers have struggled to accurately measure Betelgeuse's distance and size due to its pulsating nature, which causes its diameter to vary. Photos from the Very Large Telescope Interferometer (VLTI) in 2009 revealed a massive gas plume stretching $30 from Betelgeuse's surface, with a size equal to the Sun-Neptune distance. This mass loss remains a mystery, with astronomers believing it could provide clues to the deaths of massive stars. Red supergiants like Betelgeuse play a vital role in galactic matter recycling. In 2019, astronomers using Hubble discovered a significant surface mass ejection, SME, on Betelgeuse, expelling 400 billion times more mass than the Sun's typical coronal mass ejections, CME. This SME caused Betelgeuse's brightness to drop by about 3 times from October 2019 to February 2020, an event visible even to amateur astronomers. Additional studies in 2020 revealed that Betelgeuse's dimming might have been due to dust created by cooling gas expelled from the star's surface. Further observations in 2022 confirmed that dust might have originated from the SME, which released mass that cooled, creating a visible dust cloud that partially obscured Betelgeuse from Earth. The star has since begun to brighten, but its 400-day pulsation cycle has been disrupted. Betelgeuse's unexpected behavior has offered astronomers invaluable insights into how red supergiant stars lose mass before they explode in a supernova. This behavior, observed in recent years, involved a remarkable phenomenon called a surface mass ejection, SME, which was entirely unprecedented in both its scale and its impact on the star. Unlike typical coronal mass ejections, CMEs, observed in stars like our Sun, which expel small amounts of material from the outer atmosphere, Betelgeuse's SME resulted in an enormous expulsion, about 400 billion times greater than a typical CME. Such a significant event marked the first time scientists had ever observed such a phenomenon in a star. It showcased the dynamic and unpredictable nature of red supergiants, which undergo intense processes as they near the end of their lives. One of the most intriguing aspects of Betelgeuse's recent SME was its effect on the star's internal convection cells. Convection cells are regions within a star where hot material rises to the surface, cools, and then sinks back down, helping to transport energy outward. In Betelgeuse's case, these cells began to behave erratically, leading to movements akin to an unbalanced washing machine tub. This comparison highlights the turbulence within the star's layers, revealing an intense level of instability as it ejects massive amounts of material. This instability is thought to have contributed to the dramatic dimming event seen by astronomers in late 2019, when Betelgeuse's brightness unexpectedly decreased to levels that were visible even to the naked eye. Observations of Betelgeuse as it recovers from this mass ejection event could offer groundbreaking advancements in our understanding of stellar death and supernova formation. As Betelgeuse slowly returns to its former brightness, astronomers are closely monitoring its convection cells and outer layers, hoping to capture more clues about the processes leading up to a supernova. This kind of research may allow scientists to better predict and understand the behavior of other red supergiants, giving humanity a clearer view of the life cycle of stars and the conditions that precede a supernova explosion. Such insights are particularly valuable because Betelgeuse is relatively close to Earth, which provides astronomers with a rare opportunity to study these end-of-life stellar processes in real time. As we watch Betelgeuse recover, we not only deepen our knowledge of the specific star but also enhance our understanding of the life cycles of massive stars across the galaxy, marking a significant step in the field of astrophysics. When Betelgeuse finally explodes, it will shine as bright as a full moon for weeks, visible even during the day. However, this supernova will not harm Earth due to its distance, estimated at over 500 light-years away, 10 times farther than the danger range of 50 light-years. Instead, it will offer a spectacular sight in the night sky, and astronomers will be able to study the event closely due to Betelgeuse's proximity.